Welcome to Curie Electronics. In this video, we are going to learn about voltage comparator. We use op-amp to make this voltage comparator. And a simple voltage comparator, it is not advisable to use for practical applications. So in the next video, we will be learning how to take care of this problem. So this is a simple comparator with the LM324 comparator IC. But for practical applications, it is better not to use this configuration. For practical applications, we need comparator with hysteresis to take care of the noise. So today we will learn why we should not use this simple comparator for practical applications. So here all of you know what is the voltage at the midpoint of these two resistors. It's a voltage divider. So we should get 2.5 volt because it's a voltage divider. When we use two equivalent resistors, then we get half of the applied voltage. And here we are going to give the input. Now what is expected from this? This is a non-linear application. Okay, so what happens? The positive terminal V in pos, I will write it as input positive, that is the non-inverting terminal voltage is greater than inverting terminal, that is the in negative, I'll write it. That gives output of, what is output? It gives high. High means it will go to almost, ideally it goes to the saturation volt. So we will get a output of 5 volt. When this non-inverting terminal, that is the input positive, is less than the input negative inverting terminal, what we get? We will get a, here we will get 0 volt, or it goes to ground. If there was a negative power supply, then it goes to the minus Vsat. So simply, now we understood how it switches. As per this diagram, if input is greater than 2.5 volt, the output is going to be 0. If the input is less than 2.5 volt, output is going to be high. So we get a something like this we will get if we are applying if our input is changing. Let's see. So the same circuit I have drawn once more. See, this is 1K. Why do we use this 1K? This is a pull-up. This LM324 pull-up resistor. Pull-up resistor. You can use 1 to, I have 1 to 10K. You can use it. So this is LM324 comparator, and it's an open collector output. So only we use this pull-up, 1 kilo pull-up. Now ideally what happens? This whatever is shown, this waveform is the input waveform. Okay, and our reference voltage is around 2.5 volt. Now what happens? This triangular waveform, when it crosses 2.5 volt, when it goes above 2.5 volt, what happens? It goes low. See here it is going above 2.5 volt, then the output is going low. After that, what is happening? It is decreasing below 2.5 volt there, and up to here it is staying to below 2.5 volt. So the output is high. Because why? Because this configuration is a inverting configuration. Inverting means we are applying input to the inverting terminal. That is why, so ideally we should get this waveform. That is, when the voltage, when this ramp voltage goes above 2.5 volt, output goes to low. And again, when this ramp voltage comes below 2.5 voltage, 2.5 volt, it goes high. So this is how ideally it should supposed to work, and that is what we are expecting from this circuit, because we are given the reference voltage as 2.5 volt. Now, why we should not use this configuration? That's what we want to learn. Why we should not use? See, if you use this configuration, see, this is at 2.5 volt. But if there is a noise, what happens? If there is a noise due to internal factors or external factors, then what happens? This output will continuously keep changing. It is called chattering. We call it chattering. That means this above due to noise, this voltage area is going above and below 2.5 volt. Due to that, the output is getting on off, or output is going high low high low high low. That is why we say for practical applications we should not use simple comparator. We should have hysteresis comparator. The next video we will learn how to design a hysteresis comparator so that this we can avoid. See here, if this is a noisy input, so it is completely, the chattering is happening, the output is getting on and off. So here this is the expanded view. Okay, so this is the noise. The white color shows that is a DC 2.5 volt. Then what is happening on the DC? There is a noise. When noise is there, the output is keep on going high and low high and low. That is why we should not use this configuration for practical applications. We have to use the hysteresis configuration. So in the next video we will learn how to make a comparator with hysteresis so that we can take care of the noise. I hope these videos are useful to you. If so, please hit the like button. Also don't forget to share with your friends. Thanks for watching.